Math 3, practice 3.1.1 radians. Alright, so problems 1 through 3, we're using the information in the diagrams to find the angle measure of theta in radians. Remember that symbol stands for theta, so we want to find this angle measure. Okay. Now, we're usually pretty good with degrees, right? A full circle is 360 degrees. So we want to find this piece. Okay, but we're doing radians now. Now remember, when we're talking about radians, right, if we talk about a circle of 360 degrees, that means we can split it up into 361 degrees, right? Now when we talk about radians, radians is more the measure of the distance. Okay, and so with a radian, the idea is we take that length of the radius, and if we could, bundle this up and then measure it out along here, how far would it go? Okay, and what they discovered is that it goes about almost to 3 radians. Okay, half a circle is almost 3 radians. 180 degrees is almost 3 radians. But they had a little piece left over. Okay, and that piece was about 0.14. Okay, obviously it was a decimal that was longer, so a half circle is about 3.14 radians. Okay, which that number should look familiar. It's pi. Okay, that's where the pi comes from. It comes from the radians. But if we keep tracing around and go around the whole circle, we end up getting 6 full radians and then about 0.28. So 6.28 followed by other decimals, which we call 2 pi. Okay, so the whole circle is considered 2 pi. Now we need that information when we're trying to figure out this radian given the measure of our arc, right, which was, or length I suppose, which was 17 inches, is how big this is. Okay, and then we want to know that angle. Okay, so we know the radius. What we're going to end up setting up is a proportion. Okay, we're going to say, do we know the circumference of this whole circle? Well, remember, circumference is 2 times pi times the radius. Our radius is 4, so it would be 8 pi. Okay, so the total distance around here in this situation is 8 pi. Okay, now the total distance we talked around in radians is 2 pi. Okay, so we have the same distance, one in inches, one in radians of the complete circle. Now we want the pieces that we're looking for. So this right here is 17 inches, and in radians, we don't know what it is, we'd call it theta. So now we need to solve for theta. Okay, so many different ways that we can do this. Okay, I would multiply by 2 pi. You could cross multiply here, but I think just multiplying by 2 pi would be a little easier. So that cancels out. We're left with theta on the right side. And then I should remember from the rationals, same on top and bottom, I can eliminate, right? So the pi's eliminate, and then 8 is like 4 times 2, so the 2's eliminate, so I end up with 17 over 4. Okay, now if I want to make it a decimal, I just go 17 divided by 4 and I get 4.25. So this measures 4.25 radians. Okay, so the rest of these we're going to treat the same way. Okay, we always say we know it's going to be equal to theta over 2 pi. Okay, so now what is our circumference? With a circumference of 5, it's 2 times pi times 5. Okay, and this distance is 12. The distance in my arc, 12 feet. So once again, times by 2 pi. 2 pi's cancel, 2 pi's cancel. We're left with 12 over 5 equals theta. We type that into a calculator, and we get our answer. And that equals about 2.4. So moving on to that last one. Same idea. We've got theta over 2 pi equals 2 pi times the radius, 13.6, over 8.5, times by 2 pi on both sides. Hopefully you realize this 2 pi is kind of meaningless. We probably could have just said the length of our arc divided by the radius is going to equal our theta. So 8.5 divided by 13.6, and we get 0.625 for theta. 0.625 radians. So a little over half a radian, basically, is what we got there. Okay. So there's the first three. Now, 4 through 7 says, convert each radian measured to degrees. Round your answer to the nearest tenth, if necessary. So once again, it's a good idea to use a proportion again. Okay, so I know that my radians, like 8 pi over 9, okay, if I want to change radians into degrees, I set it equal to 180 over pi. Actually, not set equal to, times. Okay, if I times by 180 over pi, that'll give me my degrees. If I'm given degrees, then I would times it by pi over 180 to get it. So it kind of works back and forth. Okay, we want degrees, so we put degrees on top. Now, what happens when we multiply? The pi's cancel out, and then we simplify. 180 is like 9 times 20. So the 9's would cancel out as well. I've got 20 times 8, which would be 160 degrees. So 8 pi ninths is 160 degrees. Okay, so then we do the same thing for... Now, if you had a calculator, you could easily just, multiply it out with a calculator like this. So 15 pi over 11 times that by 180 over pi. The pi's cancel out. Okay, I could go 15 times 180 divided by 11 and get my answer as well. Or 15 divided by 11 times 180. Either way it works. I usually try to simplify this when I can't, so 15 times 180 divided by 11 gives us about 245 says nearest tenth. It's 45 repeated, so we'd round up to 5. So 245.5 degrees. Okay, now the 3.0672 radians, we still do the same thing, but the pi's won't cancel out. So this one's a little more just calculator work. So I'd still go 3.0672 over 1 times 180 over pi. So I just times those two, divide by pi. And that'll give me my answer. So a lot of calculator work there. And we get 175.73, so rounding to nearest tenth, 175.7 degrees. Okay, so the last one, basically the same idea, just a different number, 0.9431 times by 180, divide by pi. And we get 540.35, round to the nearest tenth, 540.4 degrees. Okay, so that's an easy way to go radians to degrees. And we could take these degrees, times them by pi over 180, and we could get it back to the same thing. Okay, and sometimes, most of the time, we end up liking to use our radians more like that in fraction form with the pi not multiplied than we do with these other ones. Alright, so 8, 9, and 10. Read the following scenario and use the information in it to complete problems 8 through 10. Mitra, Charlene, and Abby are taking turns spinning the merry-go-round at the park. Yay! They each spin the carousel at a different speed in degrees per second. How fast does each girl's spin in radians per second? Supply an exact answer and also a decimal approximation rounded to the nearest tenth. So here we go. We're doing the opposite, right? Merry-go-round is going around. They said 215 degrees. We want to know radians. So I go 215 times pi over 180. Okay, because now I want the pi. Now, the way to kind of think about this one is to think about that simplifying of rationals. Okay, that's the best way to think about it. Because first, for the exact answer, we don't want to just take a calculator and go 215 times pi divided by 180. We could. That gives us the decimal approximation, which then we, like I just did right here, 215 times pi divided by 180 gives us 3.75245 and some other decimals. It says round to the nearest 10,000th right here. So 10,000th is 4 places. So we go 5. So 3.7525. Okay. Now the problem with that gives us an idea, remembering that half of that is 3.14. We know that it's, right about there in 1 second. Okay. But the problem comes in later when we need to make that exact, because it'll help us later on. So to do it exact, I think like this. Well, 215 would be 5 times what? 43 maybe? 5 goes into 21 4 times. 20 minus, get 15, 3. Yeah, so it would be 5 times 43. 180 would be 5 times. So I'm just factoring out to see what we can eliminate here. That would go into 180. 3 be 15 minus, where did I get 16? Be 30. So 36. So the 5s can cancel out. Can 43, I don't think 43 can become anything more simple. So it'd be 43 pi, because I don't know, let's do that. The 5s cancel out. Then I go 43 times pi, but I'm not going to use a calculator to figure that out. To be exact, we leave it with the pi in there, over 36. Okay, so that's my exact, that's my decimal approximation for question 8. Okay, so we do the same thing for question 9. So I go 21 degrees over 1 times pi over 180. Okay, well 21 is like 3 times 7. I factor that one down. So 3 times 7. 180 has a 3 in it, so it'd be 3 times 60. 3's cancel, leaving me with 7 times pi. So 7 pi over 1 times 60 would be 60. Can't simplify that further. There's my exact answer. Okay, my non-exacts, I just take 21 times by pi divided by 180. And I get 0.3665 when I round to the nearest 10,000th. Same thing, basically. Approximation, exact. Exact is better for most of what we're going to be doing. Okay? Now, last problem, number 10. So 104 degrees over 1 times pi over 180. Okay, what can factor out of 104 and 180? We could do 2, right? 90 times 2. That would be 2 times 52. 2's could cancel. We could do 2 again, right? So 52 would be 2 times 26. And then we'd have 2 times 45. So the 2's could cancel out. Can the 26, that would be 2 times 13. 45 can't be done by 2. Can only do 5 and 9, which the other can't. So it would be 26 over 45. So 26 pi over 45. Because everything else would cancel out, leaving me with 26 on top and 45 on bottom. Okay, but to get my decimal, we just go 26 times pi divided by 45, or 105 times pi, or 104 times pi divided by 180. And we get 1.8151 radians. Exact decimal approximation. There we go.